Hi, this is Algebra 1, Lesson 77. We're starting on page 316. We're going to talk about consecutive odd and consecutive even integers and fraction and decimal word problems. Yay! Okay. In Lesson 76, we said that if n is an integer, then the next greatest integer is n plus 1. If n is even, then the next greater even integer is n plus 2. So if n is negative 4, then the next greater the next greater even integer is negative 4 plus 2, which is negative 2. If n is odd, then the next greater odd integer is also n plus 2. So if n is negative 3, the next greater odd integer is negative 1, which is n plus 2. If we want the next greater odd integer of that, we would add 2 again. So that would be n plus 4. So if we want a consecutive even integer, we have n, and then n plus 2, and then n plus 4, and then n plus 6, etc., etc., for odd or even. So let's try an example. Find 3 consecutive even integers such that the sum of the first and the second equals the sum of the third and negative 10. So we have 3 consecutive even integers. So we have n plus 2, and we have n plus 4, right? So the sum of the first and second, so that's n plus 2, equals the sum of the third and negative 10. Okay? Well, let's solve for n. So this is 2n plus 2 equals n minus 6, because 4 minus 10 is negative 6. Right? Let's get the n's on this side and the other numbers on this side. And we have n equals negative 8. If n equals negative 8, then n plus 2 equals negative 6. And n plus 4 equals negative 4. Right? Let's check this. So n, negative 8 minus 6 is negative 14. And that equals negative 4 minus 10. They both equal negative 14, so that checks. Let's try another one. Find 3 consecutive odd integers such that the sum of the first and the third is 7 greater than the second decreased by 18. Okay, so we have 3 consecutive odd integers, so that's n plus 2, and n plus 4. And the sum of the first and third, so we're adding n plus n plus 4, is 7 greater, so let's subtract 7, than the second, which is n plus 2, decreased by 18, so minus 18. Okay, let's clean this mess up. We have 2n plus 4 minus 7 is minus 3 equals n plus 2 minus 18 is minus 16. We get the n's on one side.
Oh, what in the world?
And all of the others on this side. And we have n equals negative 13. So the first check is we wanted odd, and this is odd. So we have n equals negative 13. So n plus 2 equals negative 11. And n plus 4 equals negative 9. So let's check this. We have negative 13 minus 9, so that would be negative 22 minus 7, which would be negative 29, equals negative 11 minus 18, which would also be negative 29. So that checks. Okay, let's try the next one. Find 4 consecutive odd integers such that the sum of the first and fourth is 25 greater than the opposite of the third. And when it says opposite of the third, that means the opposite sign. So we have 4 consecutive odd integers. We have n plus 2, n plus 4, and n plus 6. Okay? The sum of the first and fourth, n plus 6, is 25 greater, so we'll subtract 25, than the opposite of the third. Okay? Then we have negative n plus 4. We're going to multiply that times negative 1. Alright, let's clean this up. We have 2n minus 19 equals negative n minus 4. Let's get these numbers on this side and the n's on this side. And we have 3n equals 15. So n equals 5. If n equals 5, then n plus 2 equals 7. N plus 4 equals 9. And n plus 6 equals 11. Let's check this. We have 5 plus 11, which is 16, minus 25, which is negative 9, equals negative 9. So it checks. Okay, now we're going to talk about fraction and decimal word problems. Since problems involving fractional and decimal parts are essentially the same as percentage problems, your favorite, we will use the same methods to solve them. Lopez used a 5-iron, but the ball only covered 4/5 of the required distance. If she hit the ball 112 yards, what is the required distance? So we're going to use D subscript R for required distance. Okay, notice that it says 4/5 of. Just like percentages of mean we're going to multiply, 4/5 of also means we're going to multiply. So 4/5 of the required distance. So we're going to multiply 4/5 of the required distance, and that equaled 112 yards. Okay? Now we need to solve for required distance. To get rid of this fraction, we're going to multiply both sides by the inverse. So these guys cancel, and we have the required distance equals 112 times 5 divided by 4, which equals 140 yards. Okay, let's try a couple more. Maccabee guessed the total was 30.24, but this was actually 7.2 times the actual total. What was the actual total? Okay, so this number is 7.2 times the actual total. That means this number is considerably greater than the actual total. So our answer is going to be smaller than 30.24, right? These are the kind of things you need to think through so you know if the answer you come up with is reasonable. Okay, so here's a clue. 7.2 times the actual total is going to equal 30.24. So we're going to say 7.2 times the total. We have no idea what the total is, but it doesn't matter. The total of what? Equals, maybe they're guessing the number of jelly beans in a jar or something like that. Other than you would have 30.24 jelly beans, which is unlikely, but who knows. Okay, 7.2 total equals 30.24. Okay, now we're going to divide by 7.2. And the total is going to equal 4.2. Okay, let's try another one. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets were printed? 3/4 of the tickets were sold. Okay, this is one of those tricky ones. We need to know how many tickets are left. If 3/4 of the tickets have been sold, then 1/4 of the tickets are left. And we're looking for tickets left because that's the number we have. Okay? So if 3/4 of the tickets are sold, then 1/4 of the tickets are left, and we know the number of tickets that are left. So we can say 1/4 of the tickets printed, okay? 1/4 of the total number of tickets printed equals 420, because that's the number of tickets that were left. All right, to figure this out, we're going to multiply times the inverse again on both sides. And we get the number of tickets printed was 1,680 tickets. If what you have here is tickets left, then you need to figure out how to change tickets sold to tickets left. Don't multiply the 3/4 times tickets printed. That's going to come out with the wrong answer. Okay? That's it for this lesson. Try your practice problems. Do all the problems from this lesson. Let me know if you have any questions. Thank you.